Okay, so this is the homework help session with Lisa today, and I forgot to hit the record button earlier, but now that we got it on, I was just going to repeat what she had just asked. She didn't come with a specific question, just kind of a general, when you're asked to graph something in my math lab, she said, where do the values come from? Where do you start with it? So that's a really good question. And what I'm going to do, Lisa, is take us out online into my math lab. So give me just a moment to get things going on my end here, so that I can find us a question to look at together. Okay, excellent. I've got my math lab already open, and I'm going to click on homework here.
I had other questions, but I watched your quiz review, and that really helped a lot.
Yay, that's so good to hear. Awesome. Okay, let me share my desktop with you, and you should be able to see my math lab. Can you see that on your end?
It's coming.
Okay.
Yes.
All right. Let me get you back on here. There we go. All right. So you see I've just got it open to the homework tab here. And do you happen to remember which section you were in, 1-1, 1-2, or 1-3?
It's 1-1-2.
Okay. Okay, and I've actually haven't opened the textbook here yet, or the video, so let me open that so it'll let me go and look at the problem. And no, we don't want to watch the video right now. Okay, let me see. Actually, let me make this smaller so you don't keep popping off of my screen here. I like to be able to see who I'm talking to. There we go. Okay, let me see if I can locate one of those graphing questions for us. Let's see. Does this look like something you want to look at?
Yes. Yes.
Hey, Ansley, you're early. You're joining Lisa's session, but if you'd like to stay in here, I'm sure Lisa won't mind, and we'll do your session after Lisa's. We'll do a double feature here. I'll just keep the recording rolling for everybody. Okay, so Lisa, you said yes, this is one you'd like to look at with me?
Yes.
Okay, great. All right, so we have, let me get my little pens here. Let's see where my pens went. Let's see my pen.
Sorry.
Oh, I'm wondering. No, you're fine. I'm wondering if it's not going to let me look at this or draw on it. Let me see. No, it's not going to let me draw on it while I've got my desktop sharing. So I can remember that. It's x squared. Uh-oh, Ansley left. It's x squared and x squared minus 6. So I'm going to unshare my desktop and we'll go back to the whiteboard where I can write. And y'all just get to see my non-flattering hand-drawn graphs here on the whiteboard. All right, so the first one was just f of x equals x squared. We'll learn in a later section that this is considered a parent function because it hasn't had anything done to it. It's just good old x squared. So the first step that you'd want to make is to create an x f of x table for this.
And that's where I get lost, because what number do you start with?
That's a great question, and not very intuitive if you're just looking at this and I don't know where to start. So with any type of function, when you go to make the XY table, the first thing you want to do is look at the function itself and see if there are any real numbers that you're not allowed to plug into that thing. So, for example, I'm looking at this and it's x squared. Is there any real number that you can think of that you can't multiply by itself?
0.
0 times 0 is 0. That's a real number, by the way. The only numbers that aren't real are imaginary, and we haven't even started studying imaginary numbers. Let me clue you in here a little bit. So, like, if I have y equals the square root of x, I would not want to plug in a negative number there, because that's what creates an imaginary number. So, like, if I tried to plug in -4, y equals the square root of -4. This right here is asking you, what can I multiply by itself to make -4? Well, there's no real number that you can multiply by itself, because 2 times 2 is 4. -2 times -2 is +4. So with the square root function, we have restrictions on the variable of not being able to plug in negative numbers. You can plug anything 0 and above into that particular function, just nothing negative. So with our given function, though, of x squared, actually let me get this, where's my pen? There it is. Let me get this off of our screen here. With our given function of x squared, you have no restrictions whatsoever on the variable.
As long as it's a positive number.
No, with x squared, you can square anything you want to.
Okay.
-7 times -7 is 49. You're in the realm of the real numbers, no matter what you plug in there. As long as it's not, as long as it's a real number, you can plug it in. Actually, you can even plug in imaginary numbers into this function if you really wanted to. So basically, you can start your f of x table wherever you want to. Okay. If I really, really wanted to plug in 796,841 and square it and see what I get out, I could. But probably not too
start low.
Yeah, not too practical to do something like that. So the normal numbers that we like to stick around are right around the origin, because they're small numbers. They're usually shown by the graph we're looking at, the axes, you know. So what I would suggest here is -2, -1, 0, 1, and 2. Not necessary, but nice and neat.
Okay.
Okay, and then for each of these, you just plug them in to get your f of x value. So for this first one, that'd be -2 squared, which is 4. Then we have -1 squared, which is 1. By the way, whenever you plug something in, you always want to use parentheses, because you can see that negative gets squared with that and it becomes positive. And then 1 squared is 1, and 2 squared is 2. So, oh no, 4. Goodness. Temporary insanity. That's what I'm pleading. All right, so we have a start for our XY table there. And let's see. I'm going to draw a terrible graph, I'm sure, down at the bottom here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. Okay. So if I go to graph this, I'm just going to plot the ordered pairs that I found. -2, +4, about right here. You have to use your imagination a little bit on my graph. -1, -1, 0, 0, 1, 1, 2, 4. Okay, so there's our first one. And they also wanted us to graph a transformation of the parent function x squared, which, like I said, we'll talk about transformations in a later section. I believe it was x squared minus 6 was the other one that was on the screen there. So you're just going to, and let me call this g of x since it's a different function. Once again, you can choose values out of the air for this one. I'm going to stick with tried and true right there. -2, -1, 0, 1, and 2. So -2 squared is 4. 4 minus 6 is -2. You okay with that, or do you need to see me multiply that out or simplify that?
No, that's absolutely fine. That's where I didn't know that I could just, I mean,
yep.
that's
Okay.
just full numbers and start off with just, you know,
yeah.
the basic
so
ones
I'll finish this off for you, and if you don't have any other questions, we'll be done. So -1 squared is 1. 1 minus 6 is -5. 0 squared is 0. 0 minus 6 is -6. 1 squared 1 minus 6 is -5. 2 squared is 4. 4 minus 6 is -2. So we have -2, -2, -1, -5, 0, -6, 1, -5, and 2, -2. So just to clue you in, although it's hard to tell because I have a hand-drawn graph here, just to give you a little peek of what we're going to be studying in a later section is whenever you add or subtract a number outside of the function itself, which would be squaring this thing, here's the parent. All I've done is transformed the parent function by, since it's -6, it dropped down 6. 1, 2, 3, 4, 5, 6. Every point dropped down 6. And you'll learn a lot more about that stuff when we get to it.
Okay.
Any other questions?
No, that was, like I said, I watched the quiz review, and that was phenomenal. That helped a lot, and I'm going to go in and rewatch it again before I take the quiz.
That is a very, very good idea. All right, well, if you don't have any other questions, I'll cut you loose for the day. Thank you for making the homework video with me, and I'll post this for everybody else to benefit from, too.
Thank you so much.
You're so welcome. Have a good day and have a great weekend.
You too. Bye-bye.
Bye-bye.